Hello everyone and welcome to my presentation on the role of values and motivation in shaping algorithmic outcomes. Let's begin with a reflection. Some of you might remember the incident with Microsoft's chatbot a few years ago. The bot was taken down shortly after its release because it became racist after interacting with users. This is a demonstration of the vulnerability of algorithmic systems to biases from their training data or from user interactions. Moving forward to today, algorithms have evolved, but in many cases they still have problems with bias issues. Let's think of algorithms which generate images from text descriptions. Here are some images I created with such an algorithm. And I asked it for a photography of a nurse, a kindergarten teacher, a doctor, and a lawyer. And it created images which mostly show stereotypical gender roles, and people of color were underrepresented as well. My name is Zabel. I'm a PhD student at the University of Hohenheim in Germany, and together with Siegmar Otto, I conducted a study on the emergence of biases in algorithms. We explored how individual motivation shapes algorithmic outcomes, and we looked at the context of ecological and social sustainability. First, let's briefly discuss at what stages bias can be introduced into an algorithm. During the data science process, bias can sneak in at different stages. There can be biases in the capture of training data. An example for this is the representation bias, which occurs when the data is imbalanced. For example, when occupational roles were traditionally held by men and someone uses these historical data for an algorithm, the gender representation in the training data is imbalanced, and this may cause a bias. There are also biases in data curation, which is a process where human curators assign labels to the data, and their decisions can be influenced by their culture and most likely also by their personality and their values. And biases can also be introduced during the data analysis. An example herefor is the feature bias, where attributes with the highest predictive power are selected as features used in the model. And these can be biased as well. After the data science process, when users interact with an algorithm, chances are that a user-to-data bias is introduced into a model, because the interaction with users again serves as training data. An example would be the content production bias, which emerges when different populations generate different content, for example, because they use a different language or have different cultures. So there are many ways in which human influence or biases can enter an algorithm. And there are promising approaches to mitigate biases, but regulations and technical methods cannot cover all aspects and sources of bias. And that's why it's important to understand how humans can unconsciously influence an algorithm through the decisions they make in the training or in the use. And we know from research on social media content sharing that users make value-based decisions. That means their values and the related motives influence what content they share. And they will share content which is important to themselves or which they think is important for others. Following this logic, we assume that such decisions during the data science process and in the use of algorithms are also influenced by motives. Our aim was to explore whether such motive-driven decisions can create a bias in algorithmic output. So in our study, we focused on the environmental and the altruistic motivation, and we explored whether they have an influence on decisions made during the training of a spam filter. The relation between environmental and altruistic motivation with the respective behavioral outcomes in general is well researched, so our aim was to explore if this translates to the training of algorithms. We expected that the higher the environmental motivation of the people involved in the data science process, as well as the users, the less they will classify mails from environmental organizations as spam. Regarding altruistic motivation, we expected that the higher the altruistic motivation, the less likely the stakeholders will classify mails from humanitarian organizations as spam. And because altruistic and environmental motivation are correlated, we expected a spillover effect. Here's what we did in our study. We showed participants 8 mails in randomized order. And here's one example mail of a humanitarian organization. The text just says that they thank the recipient for their donation and that it helped to battle the malnutrition in Yemen. The texts were mostly adapted from real mails. And 2 of the 8 mails were from environmental organizations, 2 from humanitarian organizations. The other mails were from a bank, from the tax authority, and 1 was a real spam mail about how to become a Bitcoin millionaire. We conducted an online survey with 820 participants from a market research panel, so the sample was online representative for the German population. The participants read the 8 mails and rated the spam likelihood for each mail. And afterwards we calculated a spam ratio for environmental and humanitarian mails. That means we weighted the respective ratings of either humanitarian or environmental mails against a person's overall spam ratings. And afterwards we assessed participants' environmental motivation and their altruistic motivation. Then we conducted 2 multiple regressions. And our analysis showed that environmental motivation significantly predicts the spam rating of mails from environmental organizations. The relation is negative, so as we expected, the higher the environmental motivation of participants, the less they classified mails from environmental organizations as spam. Interestingly, altruistic motivation was slightly positively related to categorizing mails from environmental organizations as spam. The results for mails from humanitarian organizations are similar. Environmental motivation again predicted the spam rating of mails from humanitarian organizations, and the higher the environmental motivation of participants was, the less they classified emails from humanitarian organizations as spam. Altruistic motivation was not related to spam classification. To sum up, our study shows that environmental motivation is related to decision-making in a simulated algorithm training. Similar to content sharing on social media, people tend to make decisions based on their values and motives when training an algorithm. This could lead to a bias in favor of environmental and humanitarian mails if people with a higher environmental motivation trained a spam filter. Altruistic motivation was not related to decisions in our study. So what are the implications? The case of a spam filter may seem limited, but our findings extend to larger algorithmic systems. Human motives can influence the visibility of content and also the information flow through algorithmic systems. So we should consider individual motives as a source of unintended bias and be aware of this. But we should also see it as a chance. We could focus more on sustainability motivation in the development process. For example, by integrating this value more deeply into a company's culture, or by training data scientists to increase the sustainability motivation. And then the resulting algorithms may be slightly biased towards sustainability. Thank you very much for listening. I'm happy if you write me an email in case you have any questions or suggestions.